Hey guys! So today we're going to talk about energy, and energy is a part of our everyday existence.
Whether that be from the food that we eat that gives us energy, or coal that's consumed by machines that gives the machine energy. So the concept of energy is familiar to people, but it's hard to define.
We define energy as the capacity to do work or to produce heat. So just to remind you of what heat and work are, work is a force acting over a distance that causes something to move, while heat is the transfer of energy between two objects due to a temperature difference.
So we should all, or hopefully all, know that energy cannot be created nor destroyed, and that energy of the universe is constant according to the first law of thermodynamics.
So moving on to enthalpy. Enthalpy is defined as H equals E plus PV, which is also down below so you guys can see. So we are not really interested in the total enthalpy, so we just use this formula, which is down below, which is delta H equals heat plus work plus volume times pressure to find out the change. So in enthalpy, which is also known as delta H, in those kind of reactions, the exothermic reactions are usually generally favored more.
Standard enthalpy of formation is the amount of heat gained or lost during a reaction. Entropy, also known as delta S, is the disorder of a system.
So now we're going to talk about Hess's law, and Hess's law is when the enthalpy change for a reactant is equal to the sum of the enthalpy of formation of all the products minus the sum of the enthalpy formation of all of the reactants. So there are more ways for things to be out of order than in order. So just like an example would be like how your room gets messy after like a busy week of school and homework and everything else.
Yeah.
So it's a natural tendency for things to get disordered. So this is also called entropy. So it's also defined as a disorder of a system, which is also known as delta S. So more disorder is actually favored. Okay, so if you guys want to mess with your parents, you can tell them that the reason why your room is messy is because of entropy. Don't try this at home, guys. Don't do it. Don't try. I was kidding. Okay.
Something that goes along with what Tracy just said is the second law of thermodynamics that states that in any spontaneous process, there is always an increase in entropy in the universe.
Okay, so basically what she was saying is that the entropy in the universe is increasing because nature favors disorder. So we can express delta S in the terms of delta S equals negative delta H divided by temperature.
Another thermodynamic function that is also related to spontaneity is
free energy!
And it's especially useful in dealing with the temperature dependency of spontaneity.
So this function is called free energy, as you can tell. Which is symbolized by G and is defined by the relationship of this formula, which is G equals H minus TS. So this is where H is the enthalpy and T is the temperature in Kelvin and S is the entropy. So now let's talk about equilibrium.
So equilibrium is defined differently in this section because we are talking about energy. So from the thermodynamics point of view, we define equilibrium as the lowest value
of free energy available in a reactant system. Okay, so let's talk about the equilibrium constant. So the equation that we use is right here, which is delta G equals negative RT times natural log of K. Hi guys, thanks for watching our video, and here's a few things that you guys should have learned throughout our video. I put bloopers around. Hey guys! Do that again.
The concept of energy is familiar.
Okay.
As they could.
So moving on to enthalpy. Enthalpy. What did I say? Enthalpy?
Enthalpy.
Just start holding you. Next frame is just like, so.